Hello guys, in this video I will give you an idea about local extrema. Um, First of all, let's talk about some vocabulary. When we say local extremum, we are talking about a single point that has minimum point or maximum point, just a point, singular point. But when we say local extrema, we are talking about many points, local minima or local maxima. We have more than 1 point. So the plural version of local extremum is local extrema. The plural version of local minimum and maximum is local minima, local maxima. So to understand questions, knowing these vocabulary is important, of course. So let's talk about how to find local minimum and where local minimum or maximum occur in the graph. So first of all, we have to have a critical value. If there is no critical value, we don't talk about local extrema. Okay. So first we have to have a critical value. So when we have a critical value at, let's say, x equals c, then we can have a local minimum if that point is the lowest point around, like in this figure, in this graph. At C, the graph, the point is the minimum point around, so we can say this point is local minimum. Okay, in other words, we can say the graph, the curve changes from decreasing to increasing from left to right, then there is local minimum. What about maximum? We must have a critical value, of course, and then we have local maximum if this point is the highest point around in the neighborhood. If this is the highest point on this on this graph, then we can say it's local maximum. In other words, we can say the graph is changing from increasing to decreasing, then local maximum occurs. Okay. Now let's take a look at an example. In this graph, let's identify minimum and maximum points. So at this point at A, we have local minimum, and we can say there is a minimum because there is a critical value. A is a critical value. We have a critical value because at that point the derivative is 0, right? The function is constant at that point and its derivative is 0. We have horizontal tangent line, we can say. The second point, B, this point is the highest point around, so we can say it's the local maximum point. So if there is a local maximum, then there has to be a critical value. So B is a critical value because it makes the derivative 0. The third local extrema, here we have C. At x equals C, we have a local minimum. This point is the minimum point around. Because we have a critical value, because that point, the function is undefined. Remember, for critical values, we have two situations, whether the derivative is 0 or it's undefined. So derivative is undefined here. Finally, we have x equals d. At this point, we have a peak, the highest point. At this point, we have a maximum point, local maximum. We have a maximum point. It means that we have a critical value at d. If d is a critical value, the derivative is either 0 or undefined. Here, since we have a corner, derivative is undefined. Here we had like cusp figure, here we have a corner, so the derivative is undefined at these two. For the other two, derivative is 0. Okay, so we can say as a note, whenever there is local extremum at a point, then there has to be a critical value at the same point. You know the conditions of having critical value, whether the derivative is 0 or undefined. But the converse is not always true. You cannot say there's critical value, then there is extrema. The opposite is not true. So we should say local maximum or local minimum points occur only at critical points, but critical numbers don't always yield local extrema. Okay, so just because we have a critical point doesn't necessarily mean that we have extrema. We have to be careful. Okay, let's take a look at this example to see this situation. At C1, at x equals c1 here, for example, in this graph, the derivative is 0 here because there is horizontal tangent line. When derivative is 0, we can say c1 is critical value. Even though c1 is critical value, it doesn't yield a local extrema. It is neither maximum nor minimum. Okay. At c2 there is maximum and c2 is critical value then. At c3 there is a minimum point, so this is critical value. It makes the denominator it makes the derivative 0. c4 derivative is undefined, so it is critical value. It yields local maximum. c5 it doesn't yield local maximum or minimum, even though the derivative at this point is 0 because there is horizontal tangent line. It doesn't give us local extremum, so no local extremum. So this note is important. Whenever there is local extremum, there has to be critical value, but if there is critical value, it doesn't necessarily mean that we have local extremum. Let's take a look at this question finally. Which of the following has a local minimum? It's exercise questions. So here I see a minimum point. There is a minimum here. Here I see a minimum point. Yes, but here no minimum point. This is minimum, but this is excluded. So there is no minimum point here. This looks minimum, but it is not a point. It's empty. So there is no local minimum. Just those two graphs yield local minimum points. In the next video, I will be explaining how to identify local minimum, local maximum by using the functions algebraically.